I said we're going to have to just do from a graph. Okay? So what I'll do then is I'm going to draw some graphs for you and see if you can tell me what the range is of each one of them. Okay, I'll just leave that one like that. So I'll give you a second to copy those down. All right, so that first one, what's the range? What y values is that function defined for? There you go. Yep, 1 to infinity, not including the 1. So a range 1 to infinity, because of that asymptote, we don't include the 1. Okay, yeah? Well, if it were, like the fact that it's an asymptote, we know for sure it doesn't include 1, because it's never going to actually reach it. If it was something like, if I drew it, like let's say it was a parabola, and I had it come down like this, do something like that, where there was actually a point right there, then we know it's actually going to hit 1 and come back. But yeah, the asymptote kind of gave it away for this one. Okay, the second one, what's the range? Negative infinity to infinity. Keeps going up, keeps going down. It's going to hit all of them. Good. Okay. And as we get into some of the piecewise function stuff later, we'll do some more of this kind of thing with the graphs. But just wanted to make sure you guys were still thinking this way about range. Okay. Symmetry, real quick, we'll do next. Okay, we got two different kinds of functions when it comes to symmetry. We call them even and odd. Bless you. An even function is if f of negative x equals f of x, is the definition of that. And an odd function if f of negative x equals negative f of x. Now this you probably don't remember, but identifying them on a graph you probably do, okay? Because that was a little bit easier to see what was going on, because there's some distinct characteristics for each of these. So, about even for a minute here, okay? To be even, negative x has to equal f of x. So let's say at negative 1, my function is up at a value of 2. What does that tell me about the value of the function at 1? It has to also be at 2, right? F of negative x equals f of x. F of negative 1 equals f of 1. So they have the same y value, right? So this one also has to be right there. Okay. Say at negative 2, my function is at 1. So what has to be true about f of 2 then? I think I heard somebody whisper it, but what has to be true of f of 2? What's the value? 1. Yeah, it's got to match the other one, right? F of negative 2 equals f of 2. They have the same y value. Let's say at 1/2, we're at, or negative 1/2, we're down at 0. So at positive 1/2, we're at 0. Negative 1.5, maybe it's at like 2.5. So positive 1.5, it's at 2.5. Okay, so, and then maybe at 0, we're like down here or something at negative 1. So the point is, though, as you start to kind of sketch this thing together, what do you notice about the shape of it? Okay, so it has kind of this, it has this kind of reflective quality then, though? They have to both be going towards the same thing in the middle? Okay. Any even function will do that because of the nature of this, right? Whatever the negative number is here, the positive number on the other side has to have the same y value. So you create this symmetry, okay? There's a line of symmetry with even functions down the y-axis, okay? So the one way that we were checking for even functions last year was, can you reflect it around the y-axis, okay? So give myself a little more room here. So if it's even, it has reflection symmetry about the y-axis. So that's a real quick way on a graph to identify if something is even. All right, now odd, it's kind of the same game. Make this one a little bit bigger. Okay. So with an of negative x equals negative f of x. So let's say I have at negative 1, I'm up at 2. So if it is odd, and f of negative x equals negative f of x, what should be the value of f of 1? Negative 2. Mm-hmm. So it's going to be down there. All right, so let's say at negative 2, I got a value of positive 1. So what's the value of f of 2? Negative 1. Mm-hmm. And if, let's go out one more. So let's say at negative 3, we've got a value of, how about negative 2? Then what's the value of f of 3? Positive. Yeah, positive 2. And then maybe like 0 is 0. So then this one starts to take on this kind of a shape. Okay. So with these don't have that line of reflection anymore, do they? Okay, if I were to take like this half and reflect it over, it's not the same, right? What did we say about odd functions, though? What's the way that you can kind of think about them in your head to check? What was it? Yeah, it's got rotation symmetry to it. Okay? if you rotate it 180 degrees, it should be back on top of itself again. So like this maximum point would swing around to where this minimum point is and vice versa and everything in between. Okay? So odd functions have rotation symmetry. So we say it has rotation symmetry about the origin. Okay, so that's even and odd. All right, just a little quick review. Do you guys remember why they're called even and odd? We did kind of a little investigation like halfway through the year last year talking about that. All right, I'll see if you can figure it out here. Think polynomials. F of x equals x squared, parabola. Think about it. What kind of shape does it have? Is it even or odd? Even. X cubed. Think about the graph. Is it even or odd? Odd. See where this is going? Okay. So x squared is even, x to the cubed, x to the third is odd, x to the fourth is even, etc., etc., okay? It came from a study of polynomials, okay? There was somebody, I don't know who, that was initially studying polynomials and looking for properties of those and recognized the symmetry effect that was happening to every other one. And so just started titling them that. There's the even functions, there's the odd functions. But then that idea could expand to other functions that didn't have powers that were even or odd numbers. So that's kind of a little backstory for you with that. But so knowing what your graphs look like, though, your 12 basic functions we talked about last year, that's going to be increasingly important too this year, because sometimes you're only going to be given an equation and you're going to be asked to identify, is it an even or odd? So if you know what the basic shape is based on its parent function, and then if it's been, transformed in any way, then you can identify what kind of symmetry it has as an even or odd function. So you'll be doing a bit of that in your homework as well, is doing some of that identification stuff. Piecewise, I think that's where we'll finish up here today.